Alright guys, here we go. So notes 11, we're really close to doing transcendental derivatives, which means the derivative of e and the derivative of ln of x. We'll get to those pretty soon. So this is kind of like a recap of everything we've done. We are due for an exam because we've already finished product rule, quotient rule, chain rule. We actually should have taken an exam like a while ago maybe. But we're kind of like in the middle between Unit 2 and Unit 3. Like we keep going back and forth between the units. So maybe we'll just combine both of them because I think there's E and ln on Unit 2, and we haven't covered that. So we'll see. So heads up, we're probably going to have an exam soon. What's up? No, we made yesterday a study hall day. But here we go, guys. So question number 1. It wants the derivative. Notice that I have a lot going on. I have to do product rule in combination with chain. So hopefully by now you're getting pretty close to being pros. So here we go. dy dx equals first. So I'm going to write cosine of 2x squared times the derivative of the second. So here's my second. On the side here, I'm going to write cosine x to the fourth power on the side. So when I take the derivative, it's going to be 4 cosine x, close it to the what power? 3, and I'm not done yet. I still got to take the derivative of cosine, which is negative sine. So there we go. Plus second cosine of the fourth x times the derivative of the first. The derivative of cosine is negative sine. Keep the argument, 2x squared. Am I done? Times the derivative of 2x squared, which is 4x. Close. And now you just make it pretty if you wanted to make it pretty. Let's see if we can. dy dx equals, so I see a negative 4 cosine cubed x sine x cosine 2x squared. You can't combine that cosine and that cosine because they have different arguments. And then let's see, minus 4x cosine 4x sine 2x squared. You might be able to do some type of property with cosine 2x squared and the sine 2x squared, but we're going to leave it alone. How do we feel? Okay. You feel pretty comfortable with those guys, hopefully? All right. Any questions on that? Yes. Sorry, miss. Math life doesn't slow down. No, I'm kidding. I'm 100% joking. That was supposed to be funny, but it wasn't funny. What's up?
I think this is the way you're putting the order of it. I can see the next step is the 4, but after that I'm like, because in the first one, you do whatever was in the parentheses first, and then you put cosine. And then the second one, you put the first cosine to the fourth, and then you put whatever was in the parentheses.
Let's see. First times rid of the second.
No, I understand that. We wrote it at the bottom.
Oh, down here? Oh, it doesn't matter. This is all a product. All of that is a product. It doesn't matter. ABC is the same as CBA. You know what I mean? Like the product of ABC is the same as CBA. Any questions? Anyone else? Yes. I mean, if you want, you can just leave it like that. But make sure, if you remove this parenthesis, it is now wrong. Why? Because it looks like subtraction. So make sure, it's all supposed to be a product. So that's why I always put the minus in the front. So there it is. All that is a product. You know what I mean? So you can leave it alone in the back. Just make sure that you have parentheses all over the place. If it's free response, yes. If it's multiple choice, you probably have to do algebra to it. All right, here we go. On this one, before you do anything, I would rewrite it. Y equals giant parenthesis 5x cubed plus 4 over x plus 2. Close it to the 1/3. Can we do that?
Yes.
All right, next, I'm going to take a derivative. dy dx equals 1/3, giant parenthesis, leave the inside alone. 5x cubed plus 4 over x plus 2, close it to what power? Negative 2 over 3. And then times, I'm not done yet, now I'm going to do the derivative of the inside. What rule do I got to use? Quotient. Bottom, x plus 2. Notice I put parentheses right off the bat. Times derivative of the top. 5, 10, is that 15? 15x squared minus top. 5x cubed plus 4 times derivative of the bottom. 1 all over bottom squared. I don't see anything that combines. You cannot multiply those two fractions. But later on, you're probably going to have some questions on UH where they are multiplying them. Right here, I don't see anything that combines. So I would just leave it alone right there. Are we okay so far? Okay. Yeah, sometime in the future, you're probably going to have something like 1/3, 5x cubed plus 4, x plus 2. Yeah, no square root. And x plus 2 squared and stuff over there. And then see, x plus 2. So you're going to have a x plus 2 cubed. But that's later on, not right now. That's not part of that answer.
Could you still do that if it was to a negative exponent? I guess you're
No, I mean, that negative exponent means like it's going down, right? And then, I mean, yeah. Well, I mean, yeah, I guess you can, that's negative 2/3 there, and that's negative 2/3 there, and then move that up and move that one down. I guess you always can. You can just do algebra. Yeah, correct algebra is correct algebra, so I guess you can. Cool. Okay. Any other questions, guys? Okay. Yeah, when we start doing inverse trig, they're going to be doing that a whole bunch of like algebra. You'll see, because we're pretty close to it. So when we get there, you'll see what's up. All right, on this one here, hopefully by now you're starting to get kind of the hang of it, guys. This is cosecant x to the third power like that. If you feel like you're pretty strong, you no longer have to do this. You can just do the derivative immediately. Like, Chavez, what are you talking about? If you feel that you can just see it already, you can just go right into the derivative like that. 3 cosecant squared x times, what's the derivative of cosecant x? Uh-oh. Positive or negative? Cosecant x, cotangent x. If you don't see that, then don't worry about it. Do it with the parentheses. Here it is. I'm doing it again. F prime of x equals, bring the 3 to the front, cosecant x, close it to the power 2, see? Times derivative of the inside, negative cosecant x, cotangent x, which is the same thing that I have on the right-hand side. But that's only if you feel comfortable, like that you feel that you can do that. If you don't feel that you're comfortable yet, then don't do it. Cool? I would definitely distribute this. F prime of x equals, I see that this is x and I see that that's x, so I can combine those. So negative 3 cosecant cube x, cotangent x. Do you guys see what we did there?
Yep.
Okay. How are we feeling, guys? All right. So question 4, it says, yes. What's up?
Never mind.
No, ask. It's all good, miss.
No, because I thought the answer was negative 3 CSC squared x, but that's
Yeah, because of the cosecant x times. Okay, got it.
the negative's not positive.
Perfect. Given f of x equals 3 tan squared, write the equation of the line tangent when x is 7 pi over 6. So here comes pre-cal. It's never extreme pre-cal. It's just basic. I need two things. What and what? Point and slope. So here we go. I need to get a point first, so I'm going to plug in 7 pi over 6. So 3 parenthesis tan of 7 pi over 6, close it, squared. So let me do a quick recap. Here is your unit circle, 7 pi over 6. Where's that? Third quadrant, that coordinate happens to be what? Yeah, and that you should have learned in pre-cal. If you don't know it, who is your pre-cal teacher? I need to talk to them. I'm kidding. That's a joke again, but my jokes are being lame today. I apologize, guys. All right, here we go. Tan to 7 pi over 6. So 3 parentheses tan is y divided by x. Y divided by x are both going to be, no matter how you cut it, it's going to be positive because I'm squaring it anyways. But negative divided by negative would have been positive anyways. So 1 over square root of 3. Does everyone know how we got that? And I still got to square it. You don't have to rationalize it. You can if you want. But because I'm squaring it, the radical is going to go away anyways. So here we go. We have 3 times 1/3. So what's my slope? What's my y value? 1. That's not my slope yet. So here's my point. I'm going to go to the side and I'm going to write 7 pi over 6 comma 1. Not to be confused for the unit circle. That's my point. Now I'm going to find my slope. So I'm going to write f prime of x. And let me slow down so I can see some of you guys still writing. I'm going to do chain rule. What is 3 times 2? So 6 tan x, close it, to the power of 1 times the derivative of tan, which is secant squared x. There it is. So now I'm going to plug in the value 7 pi over 6. So f prime of 7 pi over 6 equals 6 times, we already said tan of 7 pi over 6 was what? 1 over square root of 3. And for now I'm going to keep it. I'll rationalize it later on. And then secant is the reciprocal of what? Cosine. So the reciprocal of cosine is a negative 2 over square root of 3. OMG. When I multiply, the square roots go away. So there was no need to rationalize from the beginning. Oh yeah, squared. Thank you. I would have gotten it wrong. We still good? So let's see. 6 times 1 over square root of 3. So I might have to rationalize. And then let's see. 2 squared is 4. Square root of 3 squared is 3. So 6 times 4 is 24 over 3 square root of 3. Well, if we don't care, I think Delta Math did care. But if we don't care, you can just write it like this. Y minus 1 equals, this is my slope, correct? 24 over 3 square root of 3, parenthesis, x minus 7 pi over 6. And I kind of want to see this tangent. Do you guys want to watch this tangent? Yeah, I kind of do. So let's go to Desmos really quick. What are you trying to do? Upload what?
Like a background, like graph and stuff on the calculator.
Oh yeah, there is. I don't know how, but I can figure it out. All right, what was the equation, guys? What was my original? Y equals what?
Y equals 3 tan squared x.
Equals 3 tan x. I guess I'm going to have to put that in parentheses there. Actually, it might work right here, right? Let's see. Yay, it worked. Okay, and what was my tangent line? Y. Oh, yeah. Yes. Yeah, I should have reduced it. My bad, guys. Yeah, look at that. That definitely looks like a tangent. Bam. I kind of want to see the point now. You know you can see a point on this? You can just type 7 pi over 6, comma, check it out. So we can see the tangent point, comma 1. Bam, look at that. Yeah, Desmos does a lot, guys. We can even label it. You can call it a name. Point. And look. All right. I thought that was cool. So Desmos is very strong, very powerful tool there. All right, let's go to the next one. Same thing. Now we're just getting practice. So it wants, write an equation on the line tangent y equals f of x at x equals 5 pi over 12. So what do I need? I need two things. Point and slope. So let's get our point. 5 pi over 12, comma, well, let's figure out what that is. F of 5 pi over 12. Travis, I don't know what 5 pi over 12 is. Well, let's see what happens here, guys. 3 times 5 pi over 12. How many times does 3 go into 12? 4. So now notice 2 sine 5 pi over 4. Notice that is a common angle. So let's see. 2. What is sine of 5 pi over 4? Yeah. Negative square root of 2 over 2 because you're in quadrant 3. Cool or not cool? Yeah, you're right. Man. All right. So now what is my y value? So I got my point. My point is 5 pi over 12, comma, negative square root of 2. Now I need to find my slope. I'm going to take a derivative. It looks like chain rule, but it's not a fancy one. So let's see. The derivative of 2 sine 3x is going to be 2 cosine 3x times 3. If you feel that you're pretty advanced, then you could have just done it immediately. 6 cosine 3x. We're not there yet, but second semester we'll just go ahead and just do that. But for now, 2 times 3, 6 cosine 3x. Now we're going to find what our slope is. So I'm going to write f prime of 5 pi over 12. And let me let you guys catch up. 6 cosine 3 times 5 pi over 12. The same deal happens again. So you have 6 cosine 5 pi over 4. So I feel like they're kind of being nice to us on this one. Because 5 pi over 4 is the same value for cosine and sine. So 6 times a negative, bless you squared. Square root of 2 over 2. 2 goes into 6 3 times. So negative 3 square root of 2. Are we okay so far? That wasn't even a joke, guys. You guys don't laugh at my jokes, but then I see how it is. Nah, I'm kidding, guys. We're good. Y minus, what was it? Square root of 2? Negative square root of 2. So y plus square root of 2 equals negative 3 square root of 2, parenthesis, x minus 5 pi over 12. This one doesn't seem as interesting, but we could watch. If you guys want, we can look at it. Okay, let's see. Let's clear everything. Okay, give me the original equation. Y equals 2 sine 3x. This one doesn't seem as interesting because it's just a wave, but that's fine. And y minus, y plus, right? What was my tangent?
Y plus square root of 2 equals negative 3 square root of 2 parentheses x minus 5 pi over 12.
X minus,
Sorry, negative 3 square root.
oh man, negative x minus 5 pi over 12.
5 pi over 12.
All right, let's see it. Where are you? There it is. And let's figure out that point just for kicks, my tangent point. What was the coordinate again? 5 pi over 12, comma, negative square root of 2. Yeah, that looks right to me, guys. Check it out. Cool? All right. Use the chart to find h prime of 5. Okay, so hopefully you guys have already mastered this because we had a whole bunch of delta questions on these. So number 6 is just, all right guys, focus. Number 6 is just chain rule, basic chain rule. So here we go. H prime of x is equal to derivative of the outside. So f prime, leave the inside alone, times derivative of the inside. And we're just going to plug in. That's it. That's all you're doing. Now you're just plugging in h prime of 5 equals f prime of g of 5 times g prime of 5. So first, look up g of 5. What is g of 5? So now it's going to be f prime of 12 times g prime of 5. This is a good example. So now f prime of 12, we look for f prime of 12. What's f prime of 12? Negative 4. So negative 4 times what's g prime of 5? 7. Sorry. Yeah, that question looks like it's from DM. So negative 4 times 7. So there it is, guys. So h prime of 5 is just negative 28. And there's a whole bunch of questions like that on DM. Oh, but now, well, now we know.
I didn't understand the box. Does that make sense? Like I didn't understand.
Oh, it's just telling you values. So here are values at 5 and 12. So f of 5 is negative 7. F prime of 5 is negative 11. You know, just that's what it means. Cool or not cool? Okay. All right. What rule do I got to use for number 7? Product. So here we go. H prime of x is equal to first times the root of the second plus second times the root of the first. I recognize some of you may like the other way around. It's not a big deal. It's not a big deal because of the plus symbol. And then we just plug in. H prime of 5 is equal to f of 5. We'll figure out what that is. G prime of 5 plus g of 5, f prime of 5. So let's plug in. F of 5 is 11. I wish it would have given me more values here. G prime of 5 is negative 2. G of 5 is 12. And f prime of 5 is 7. So let's see. Negative 22 plus, what's 12 times 7? 34? 84. Yeah, of course. What's negative 22 plus 84? 62. There it is, guys. Yay or nay? Yay. So do you guys feel like you're pretty beast at that? All right. Number 8. So given the graph f and g, notice that these graphs are piecewise functions. They're all linear. Do you guys notice that? Perfect. So determine h prime of negative 6. Okay, this looks like chain rule. So first I'm going to go h prime of x. So take the derivative of the outside, leave the inside alone, times derivative of the inside. So hopefully by now that's almost automatic, hopefully. H prime of negative 6 is equal to f prime of g of negative 6 times g prime of negative 6. Are we okay so far? We look up g of negative 6. We go to the graph that says g. So g of negative 6, it looks like it is negative 4. So I'm going to write f prime of negative 4 times g prime of negative 6. Now we're ready to evaluate. So f prime of negative 4. Go to your f graph. Go to negative 4 and look and find that slope. It looks like it's 1. Yeah, it is. Up 1, right 1, up 1, right 1. Make sure your scale is 1, right? And it is. The x and y axis go up by 1. Sometimes they trick you and they'll put, I don't think delta mass tricks you, but sometimes UH will trick you and they'll give you a different scale. And if you didn't look at it. All right, look at the g. So g of negative 6, what do we got there? Yeah, it looks like negative 1. So that means that h prime of negative 6 is nothing more than negative 1. How do we feel, guys? Awesome. And last one. Yay. Let f be a differentiable function, and they give you a whole bunch of stuff. Let the function g of x equals f of 3x. Write the equation of the line tangent to the graph of g at the point where x equals negative 1. First, I need a point, because they want a tangent line, right? So let's find our point. G of negative 1 equals f 3 times negative 1. So that is f of negative 3. So I go to f of negative 3 and I get negative 2. So my point is negative 1 comma negative 2. Is everyone okay with how I got that? Okay, next, I'm going to take a derivative. So g prime of x equals derivative of the outside, f prime, leave the inside alone, 3x, times derivative of the inside, 3. So g prime of x is equal to 3 f prime of 3x. Now we're ready. I'm going to plug in negative 1. So g prime of negative 1 is equal to 3 times f prime. 3 times negative 1 is negative 3. So let's see. 3 times f prime of negative 3. I looked that up. F prime of negative 3 is 4. So 3 times 4 is, that's my slope. Here we go. I'm just doing point and slope formula now, guys. Y plus 2 equals 12, parenthesis, x minus, plus, 3, close. What? Oh, sorry. Yeah, it is, 1. Sorry, I heard someone say 3, or maybe my imagination.